Okay, the first thing I need to do here is figure out what size bar I'll need to make my shaft fixture. So it looks like a 1/2 inch. It's over 375 for inside here, so I'll have to go to the next. I don't think I have 7/16, so I'll just go to 1/2 inch. I'm pretty sure I got a 1/2 inch, either aluminum or steel. I like to use steel if I could. So I'll see what I have in 1/2 inch, or what I have in steel bar that I can make the shaft fixture with. Okay, this will work real nice here. That's a piece of steel I was using for my Dremel project. Okay, the first turn is to get it down to about 3/8 inch diameter, roughly, to fit into the tailstock. Alright, that's the tail shaft. That'll go, or tail shaft that goes into the tail stock thing here. That'll work out good. Okay, next thing to do now is put this in the other direction here now, and then turn down for the actual motor flange, the motor shaft diameter now. That's next. Okay, now I'll be machining this down so far, leaving a small flange here for a plunger. But I have to machine this down exactly what it needs to be now to fit one of these here bearings here. This bearing goes over the motor shaft, and so now this has to fit over this here, so that the motor shaft and this is about the same diameter now whenever I get finished machining this. Okay, using my micrometer here, I'm able to get an accurate measurement here on the motor shaft itself. It's around 393, close to 394. Okay, using the old fan bearing here, I'm determining here a line right here. I'm determining how much I want to use for the actual fixturing, and then I'll machine to that line right there. Five, 10, 20, 20, 35, about 40,000 to go yet. When I get within about 10,000, so I'll start using my micrometers, and then when I get closer than that, I'll start using the actual bearing to test fit it. Okay, here's the bearing. Very close. I'm at about 95. I need to go to about 93, 94, so very, very close. I'm going to take a very small skim and then polish it with sandpaper and see how close we get to the bearing. Okay, using my micrometer, I'm pretty close to about 397, 98 back here, 97. So I still got about a couple thousand to go yet. Not quite yet. About 395. Okay, I'm right down to about 390, around 397 right now. Around 397, and what I'm doing, I got a nice, very nice smooth fitting here. What I'm using now is I'm using my crank here, and I crank the carriage. By using this here like this here, I can crank the carriage now. And I'm getting a nice smooth cut that way there. So what I'll do is I'll take it another couple thou, and then I'll just use this crank, and I'll take it in very nice and slow again, and get a nice cut. Touch off here, back to my 0. I'll take about 2 thousandths here, and I'll get this lined up here. Nice fine feed it takes now using the crank here. Okay, now I'm backing out the cut. Another direction here to clean up any. Alright, let's see what we got. I'm at 393 and a half. 393 and a half. And the shaft is around 393. So I have to take a half a thousandths off this, which would be a very thin shaving, which would probably be more like a polish with some sandpaper to get that last half thousandths. Here's the bearing itself. Just barely goes on, just starting to. I think I'm going to polish that now with some sandpaper in the file, see how that works. Okay, now here's where I'm at with this here. I have this polished down and filed down. That took that half a thousandth off, and the bearing goes on very nice, very smoothly. But now I need to show you what I'm coming on to in this. Now I built this here as a shaft fixturing. It's a fixture so that I can put my flange piece on and use that to slide into the fan housing. Okay, so this fixturing is sitting at, let me check here my micrometers, and this is sitting at the, this is sitting at around 393 and a half, as we said before. Now as I come over to the motor shaft itself, this is sitting at about 292 and a half to 293. So what I need to do is I have to get this fixturing down. They can't be larger, it's got to be smaller. It's got to be exactly the same size as the motor shaft for ideal. But it should not be bigger than the motor shaft, because then when I go to use this as a gauge, whenever I go to make my flange bearing, I'll be using it as a gauge. That means the flange bearing then will be larger, and that will be larger on here, which I don't want. So I want this to be either smaller by no more than a half a thou, or the same size as this here. So all I'm going to do is I'm just going to take my file, and I'm just going to bring that down that last half thousandths or so until I get this to almost exactly where the same diameter as this is on the motor shaft. So what I did here is I locked my micrometer on this shaft right here, and I'll use this now as the gauge whenever I go to file this down now. I'll use this to gauge, and so whenever I get this here to line up on there, then I'll know I have it then. Okay, and that's it right there. It settles down in there now really good. Okay, so that there, the shafting is now done for being the fixture. And next thing now would be to machine the actual flange bushing itself now, and use this now as the gauge for the bore, internal bore. But before I do that, I want to square up this shoulder a little bit here first, get this shoulder squared up, and then I'll be able to use this here as a nice plunger then to make that work properly. Okay, what that does now is by squaring off that shoulder, it allows the bearing now to come in flush on the back side there. It'll meet up flush now and make a nice, this part becomes a nice plunger now to push this in evenly. Okay, there's the fixture made for that. This part here that I marked on black right here, that's the part that will go into the Joe Chuck tailstock, and this here part would be the part that will do the actual slotting, the actual fixturing for the flanged housing, which will go into the fan.